Electronics rely on three key components: resistors, inductors, and capacitors. R, L, and C. The resistor, or R, controls current flow, much like a valve restricts water in a pipe. The inductor, L, is a coil of wire that stores energy in a magnetic field and resists changes in current. The capacitor, C, stores energy in an electric field and resists changes in voltage. Resistors introduce resistance, measured in ohms, and protect sensitive components by limiting current. Inductors, measured in henries, oppose changes in current and are essential for filtering and energy storage. Capacitors, measured in farads, store charge and block direct current while allowing alternating current to pass. Each component plays a unique role in shaping how electricity moves through a circuit. Resistors convert excess energy into heat, ensuring circuits operate safely. Inductors smooth out sudden changes in current, stabilizing power supplies. Capacitors filter signals, separating AC from DC and storing bursts of energy for later use. Together, these components form the foundation of countless electronic devices. Understanding R, L, and C is the first step to mastering electronics. Their interplay determines how circuits respond to signals and power. Whether you're building a simple light dimmer or a complex radio, these three parts are essential. They're the building blocks behind everything from smartphones to power grids. Mastering their functions unlocks the secrets of modern technology. In every circuit, R, L, and C work together to control, store, and shape electrical energy. This synergy is what makes advanced electronics possible. Next, let's see how these components combine in real circuits. R, L, and C can be connected in two main ways: series or parallel. In a series RLC circuit, all components are linked end-to-end, so the same current flows through each, but voltage divides among them. In a parallel RLC circuit, each component forms its own branch, sharing the same voltage but splitting the current. Series circuits are simple to build and visualize. Just connect each part in a line with a power source. Parallel circuits create multiple paths like lanes on a highway, allowing current to split and recombine. These configurations determine how the circuit responds to signals and power. The arrangement you choose shapes the circuit's behavior and applications. RLC circuits are crucial because of their unique frequency response, especially resonance. At resonance, the inductor and capacitor cancel each other's effects, minimizing impedance in series circuits and maximizing current flow at one frequency. This selective behavior lets RLC circuits act as filters, passing or blocking specific frequencies. Radios use RLC circuits to tune into stations. Adjusting capacitance or inductance changes the resonant frequency to match the desired signal. RLC circuits also form oscillators, generating repeating signals that serve as the heartbeat for devices like computers and clocks. In power systems, they smooth out voltage, ensuring stable operation. In signal processing, they filter noise and shape signals. The balance between resistance, inductance, and capacitance gives engineers precise control over electronic behavior. Mastering RLC circuits is key to designing efficient, reliable technology. Their dynamic interplay powers everything from communication to computation. RLC circuits are everywhere, quietly powering daily life. In analog radios, turning the dial adjusts a capacitor, tuning the RLC circuit to your chosen station. Speaker systems use RLC circuits to split audio into bass, mid, and treble, sending each to the right driver for clear sound. Metal detectors rely on RLC-based oscillators. Changes in inductance signal the presence of metal. These circuits filter, select, and amplify signals in countless devices. RLC circuits combine simple parts to solve complex problems. They're the invisible force behind clear music, precise communication, and even hidden treasure hunts. Understanding RLC circuits reveals the hidden magic in everyday technology.